Hello, good morning, good afternoon, or good evening, wherever you may be. For me, it is morning, and it's the day after the recording of the last video. So I'm gonna do a quick recap just to kind of get my bearings and make sure I'm remembering exactly where we left off. So I believe where we left it was we had configured the BGP between the service provider and the customers. Well, customer, in this case, just Cisco, right? But we configured BGP between site A and B. So let's just do some quick verification. So on router 1, Cisco's AR1, if we show IP BGP summary, okay, good. We're paired up with the service provider, the magic unknown service provider, which not sure if anybody's commented on who it was yet or who it is. AR1, BR1, let's check him. Okay, good, we've been paired up. So again, 23 hours now, so we're almost at exactly 24 hours from the recording of the last one, right? So looking good. Now the challenge that we face now is we need to, like I had made mention yesterday, show IP route VRF Cisco. We need to get these routes, or this subnet 10100, which we learned through BGP from Cisco Site A. We need to get that route over to service provider router 3, because right now it does not know about 10.1, and then vice versa. We need to get these 10.2 routes over to service provider router 1. So how do we do that? So we looked at, when we built the VRF, show VRF, we built the VRF for Cisco, and we gave it a route distinguisher, and if we show run section VRF, we gave it route targets. That we've given it an import and an export route target, okay, of 65,000:1. And likewise on router 3, service provider router 3, we chose 65,000:2. So the way MPLS and LDP work together in conjunction with these labels is it uses the concept of these import and export tags or labels. So it's not to overcomplicate things, but all we really should have to do is on router 1, all we should need to do is put a route target import command for 65,000:2, because we want to import the routes or the route target labels off of router 3. And they could be on any router, right? The service provider cloud, remember, it's going to be really large. There's going to be many service provider edge routers, which are the ones connecting to the customers. So all of those edge routers are going to be learning all these various routes through these VRFs, which are using the route targets, okay? So in this particular case, it's the same customer. So you could argue, well, why did we use different route targets? I did that to kind of drill down on the point that, and demonstrate why route targets are used, how they're used, that type of stuff. So you could easily just change the route target to be the same on both PEs, and quite frankly, these routes should exchange automatically once you do that. In our case, since we made the route targets different, we need to actually add a new import command to be able to bring them in on both sides. So let's test the theory, right? And we'll quickly find out if I forgot something else in this configuration as well, because we might import the routes and we might have broken connectivity or something. So we'll have to go through it, but let's see. So we're on router 1, so we're gonna import 2, okay? So we're gonna go under the VRF, okay? And just because I don't feel like typing, we're just gonna paste all this, and we're gonna say 2, okay? So at this point, we've simply added the import of 2 on router 1. So let's check the routing table again. Okay, so that's good, right? So before, when we checked the routing table prior to that change, okay, all we saw was one BGP route for 10.1, which we were learning from site A, okay? After we put the import of 2 in the VRF, we've now got all of the 10.2 routes, which is exactly what we were looking for, right? So that's a good sign. So let's just take it one step further. Let's go to Cisco's AR1 and let's check its routing table and see what's going on. Okay, so this is where things get interesting, okay? So we aren't learning any well, hold on a second. So maybe not. So let's do show IP-BGP summary. Okay, we're not learning any prefixes from the service provider. And I believe I know why. Okay, so let's use our advertise routes command on service provider router 1, because again, I want to just take little steps here to make sure we're not overlooking something. So we're going to do, remember this is in the VRF, so show BGP, VPN v4, unicast for VRF, Cisco, neighbor 192.168, what was it, 1.2, right? Advertise routes. Okay, so what we have verified from the service provider perspective, okay, is that we are in fact advertising the 10.2 routes to Cisco's AR1 router in Site A. But we are not learning them on the Cisco router. So there's BGP, I had made mention in a couple videos, there's a lot of features and functionality that BGP supports, okay? It's the routing protocol of the internet. It's very robust and it's highly customizable or tunable. So there is a list of BGP attributes that you'll learn about how it does route, how it picks the routes that it's going to learn through BGP and then inject into the routing table itself. So there's that aspect of it. But in this particular case, we're not even learning them in BGP. So there's nothing that we can even inject into the routing table at all because we're not learning anything. So there is a loop prevention mechanism. I believe this might be a repercussion of the autonomous system number. So we chose autonomous system number 65,000 for Site A and Site B, okay? This is somewhat common practice for WAN environments because there's no need to change the autonomous system number. If you have like 150 sites and you have a different autonomous system number in each site, it's just one more thing you've got to try to keep track of or whatever. So it's a bit of a logistical nightmare. So the better way to kind of design that is to just say, hey, the entire WAN is going to use the same autonomous system number, and that'll be shared or the same across all the sites. So you don't have to track or remember or document which site has which ASN. However, it comes at a cost in that there is a loop prevention mechanism for BGP that says if I learn routes that are in the same autonomous system number as the one I have, it's most likely going to block them or deny them from being learned for BGP, and then likewise it will never put them in the routing table because it decided it didn't want to learn them anyway. It thinks it's a loop, right? It says, oh, you're coming from the same autonomous system number, and it's basically a loop prevention mechanism. So how do we alleviate that? I want to try to do, the customer, in my opinion, shouldn't be bothered with that, but let's see if we can accomplish something on the service provider side to alleviate that issue and not have to burden the customer with that responsibility. So let's see what we can do here. So do show run section BGP. If we come over here and we go under the VRF, because again, everything you're going to do with your customers is going to be specific to that VRF, okay? We don't want to be putting commands in here because that's the OS, that's the specific BGP for the cloud itself, right? It's not customer facing, so there's nothing to, we don't want to modify anything in there. We want to make sure we're in the VRF address family. So if we do neighbor And then we know that he's 192.168.1.2. Let's hit the question mark here and see, just to kind of show you, there's quite a bit of options that are at our fingertips here. So the one that I have in mind is AS-Overide. So it says, override the matching AS number while sending update. So I'm hoping what this does, right, is this will take the 65,000 from site B that it learned the routes from and essentially override it, okay? So the hope is that it will be sent over to router 1. Router 1 will receive that route, but it won't see the same autonomous system number that it has, and it won't deny the route from being learned. So let's give that a shot, and let's see if we have any success with this. So I've put that command in BGP. We got to give it a second for the next BGP update message to go out. I could clear the neighbor and kind of force it, but either way, we're going to be waiting for something. So let's just give it a few seconds, and we'll see if we've got any difference in behavior. In fact, I'll tell you what, I'll just clear it on this side. So clear IP-BGP star soft in. Let's try that. Okay, check that out. So I cleared the BGP process, okay? And now what I see is I see the neighbor, which we did before, but look at the difference, okay? So we now see 6 prefixes, okay? So that's awesome. So if we do show IP-BGP, so if we ditch the summary and just put show IP-BGP, we should see the actual specifics of the routes, okay? So now we've got the 10, 2, 1, 2, and 3. Okay, that's what we were looking for, okay? So this is good. So they're in the BGP table. Now let's check to see if they've made their way over to the routing table. Okay, so we can see the routing table got quite a bit larger, right? So now we've got all these B routes, okay? So we've learned all these BGP routes, which are coming from the other Cisco site, which is awesome. So that's kind of what we're looking for. Now, we can't necessarily do a ping yet because we haven't looked at site B yet. So if we look at site B, all right, and we show IP route, actually it may work because I believe we still have that static route, I believe. So we've got this static route that we had configured before we introduced MPLS and LDP and all that jazz. We had a static route going through a single router just to kind of simulate the WAN connectivity. So in theory, this probably will work because of this static route. But the idea is we want to remove that static route and have BGP tell us or make it dynamic. All right. So we can try to do a ping test. Let's do it real quick. So we'll do it from AR1. So if we try to ping 10.2.0.1, let's try to ping that. Okay, so it doesn't look promising. Oh, it's because of this, right? So I'm getting ahead of myself. See, and you can see the route import export just kind of reared its ugly head. So we never did the import on service provider R3 yet. So I'm a step ahead of where we are as far as testing goes. So what we need to do is we need to come over to service provider router 3, show run section VRF, and we never brought in the 1. So let's go ahead and do that. Okay, so now we've configured it to import 1. So let's check the routing table on the service provider. Again, we'll take baby steps, right? So we see the 10.1 route. We just learned it 11 seconds ago, which is perfect. So that's a good sign. So let's go one step further over to router B on the Cisco site. Let's hit the up arrow. Actually, let's just do show IP-BGP summary. Okay, we haven't learned any routes here, okay? So it's going to most likely be a similar story that we ran into with site A, all right? So remember, we didn't do the override on SPR3. we are not learning the routes as a result. So let me show you another way to accomplish the same thing as the override, but it puts the responsibility more on the customer side of things. So let's go under BGP. So let's go here. Let's go under the address family, and let's go to the neighbor and hit the question mark. All right. We still see pretty much the same features and functionality at our fingertips that we did, from the service provider side. It's BGP, right? It doesn't change. We use the AS-Overide in that example, but there's this one here. So there's this keyword says allow AS in, accept AS path with my AS present in it. Okay. Wow, that couldn't be more specific. That's exactly what we're looking for. Okay. So if we do allow AS in, all right, and let's go ahead and just clear IP-BGP star soft, and then we'll show IP-BGP summary, and wouldn't you know that now we have a prefix. So let's look to see what that prefix is. We can see that it is the 10100, which is beautiful. That's what we want. Let's see if that made its way into our routing table. I'm not seeing it. So it did not make its way into the routing table, and this is most likely because we've got, all of those, well, it might be because of this, to be fair. So, and this is why I was saying so it's not making its way into the routing table. So we're going to have a little fun here. So we still have that static route that I was talking about, right? We have remnants of an old configuration here. So let's clean on site A. Let's get rid of that static route because I don't ultimately want it there anyway. We want BGP to take its place. So we're going to get rid of this. Okay, so we're going to say no to that. All right. Now when we do that, if I show IP route, we don't see the static, but we still have all the BGP routes, which is that's what we want to see. There's no need to have a static as well as the BGP. There could be a use case for that, but we're not going to get into it right now. So let's do the same thing on the B side. Show run include route. Let's get rid of this route here. All right. Show IP BGP summary, just to show you that has me removing the route, does not affect BGP. BGP still learning the 10.1, but this time let's check the routing table and look at that. So now we have a BGP route that was learned 14 seconds ago for the 10.10/22. So why did that happen? I didn't get into the details about routing because, again, I'm not this series isn't necessarily about me pretending to be a teacher and guaranteeing that if you watch these videos you're going to pass an exam. That's not really what I'm after. What I'm after is to just show you how to have a little bit more fun with your simulations and make them a bit more realistic, and just kind of show you some of the key skill sets you need to kind of get from point A to point B. But the reason is because the static route had an administrative distance of 1, right, which beats the 20 that BGP has. So it didn't put the BGP route in the table because it wasn't better than the static route. We removed the static route. BGP was the next best option, so now the BGP route shows up. So that's kind of the idea around it. So let's go back to AR1. I think we had thrown a ping at some point. So we still don't have connectivity, okay? So this is something we've got to try to figure out, all right? So I believe I may know why this is the case as well. So what we're going to do in this example is I want to bring up a switch 1. I want to do a quick test here. Show IP interface brief. This is where the VLANs live in site A. They live on the switch. So let me try to ping 10.2.0.1. See what happens here? So from the switch, I can ping site B. So let's do a trace route just to make sure we're not hallucinating here. Let me do a no IP domain lookup just in case. So that's the ping, and then let's do trace 10201. Okay. All right, perfect. So what we see, right? So what we see is we do a trace route to the prefix or the IP address that lives in the other branch site. We go to our default gateway 10101. 10101 says, oh, I know about the route 102. You should go through the service provider cloud to get there. So it sends it over to service provider router 1, which is 11. It does MPLS label switching, okay, and we see our fancy labels. So it went through router 2, right? Then it went through router 3. We know that because we assigned those labels for this specific purpose. It lands on service provider router 3, which is the 2.1. It does what's called the penultimate pop of the label. You guys will learn more about that later. Not from me. If you want to Google it, you can. But then it gets to the service or the Cisco Site B router, and it reaches its destination. So this is great. This means that we have a functioning service provider cloud with MPLS. It's all good, but why can't we ping from router 1? It's because of where that ping is being sourced from. So that ping is being sourced from the closest interface to site B, which in our case is the 192 address. All right. So that ping is actually being sourced from here. So if I demonstrate that, so if I ping, what was it, 10201, okay, and I source it from 192.168.1.2, it should fail, okay, and I'll explain why in a second. But if you don't specify the source, it's, believe it or not, it's using that same source because it's the closest to the destination, okay. However, if I change that source to, let's say, this interface, the one that has 10101 on it, it works, okay. Here's why. If we go back to site B router 1 and we look at the routing table, we don't know about the 192.168.1. subnet. It is not in our table, okay. So that's why the router has to be sourced from an IP address that site B knows about. Site B knows about the 10101 because it learned it through BGP, which is why that ping works. It does not know about the 192.168.1, which is why that ping fails. So honestly, that's in a case like this, you don't necessarily, unless you're monitoring that interface or unless you need that interface to have network reachability, it's not going to hurt the branch site connectivity necessarily behind it. However, you can fix it. So we can do something similar like we did in site B with the redistribute connect it, right? Or we can put a network statement in BGP for that subnet. Typically in my experience, typically what happens is the service provider will inject whatever that /30 or whatever that subnet is, and that way again the customer doesn't have to be burdened with it. Okay, so let's go that route. Let's go to service provider router 1 and let's go into BGP just to kind of show you. We'll see if we can fix connectivity to that address. So you can see under our address family for our customer Cisco, we don't have any network statements. There's no redistribution, there's no network statements. We're not advertising anything, right? We're learning routes from site A and site B for that matter across the cloud, but we're not advertising anything at all. So what we'll do is we'll put a network statement in there for 192.168.1.0, okay, and that was a /30, so we know we need the mask command 252. So let's see what happens with that command. So let's go back to B, let's hit the up arrow, and let's see if we see a route, which we do. So check it out. So we now have a BGP route for 192.168.1.0. We learned it from the PE 2.1, and it's been there for 7 seconds because we just did it. So now, let's go back to AR1, and let's hit the up arrow. Which one was failing? This one, right? Yeah. So see the difference? So now it works. So now we can ping 10201 sourced from our 192 address because we've now provided that reachability in the routing table of BR1. Hopefully that makes sense. Let's go ahead and while we're at it, let's just, because otherwise we'll end up forgetting stuff later and we'll be troubleshooting for no reason. So let's go over to service provider 3, show run section BGP. And let's kind of do the same thing over here, just so we have full reachability later on, and we're not scratching our heads. I could do a redistribute connected here, and it would do the same thing. I would want to attach a route map or something here because I don't want to just bleed all my connected routes. Well, they're in a different VRF. I don't think that would matter. So forget I said that. Let's just go ahead and do the network statement. Okay, let's just do network 2.0 mask /30. Okay, and if we go over to AR1 and we check our routing table now, we should see a 192.168 2 dot. Okay, which we do. It's been there 5 seconds. So that should be all of what. So that should be a fully functional end-to-end customer branch site to customer branch site through a real MPLS cloud. I think we've got everything in place. I kind of demonstrated the AS-Overide versus the allow AS in. Again, it's situational, right? So it depends on your situation. Do you rely on a service provider to do that, or do you take that into your own hands? I don't know that there's a right or wrong answer per se. I just look at it as a situational thing. As long as you know how to alleviate those issues, right, you should be able to remediate things in a few different ways. There's 3, 4, 5, 6 different ways to approach networking. It's pretty robust as far as what you can do, and it's a matter of what you're comfortable with and your knowledge base, right? So I think we're gonna quit here. I'm debating for the next couple videos. I definitely want to introduce a data center into the mix, right? So maybe we'll throw a data center in, we'll give him MPLS connectivity, we'll give him internet access, and we can start to play with some Nexus 9K switches. We'll do some virtual port channels. We can do a lot of cool stuff there. I want to get into first hop redundancy protocols. The other option we can do is to add a different customer. So you guys can kind of see how we can have overlap as far as IP addresses go, and that it has no bearing on each individual customer. So that might be a fun little exercise. I'll have to modify the topology a bit. It's going to start to decrease in size because it's going to be the icons are going to get smaller, but the topology is going to get larger. We're going to be adding a bunch more stuff. So I think maybe we'll go that route next. We'll do another customer. We don't have to make multiple floors. We'll keep it simple, maybe a router and a switch. And then from there we can hop into some data center stuff. I wanted to just really quickly too, I almost forgot. So when we were talking about the route targets, when we first joined the call today or the session today, one of the first steps we had to take was importing the proper route target from the other site, right? There's some cool use cases with that as well. So like, if I'm the service provider, all right, and let's say let's just say that this customer wants internet access, right, through the service provider, through this MPLS service provider. Let's just pretend that he has connectivity to the internet, all right? What you can do is you can have a route target that's kind of, we'll call it 7029, right, :1, okay? and that never changes. That is the route target for this service provider to offer internet services to any and all of its customers if they need it, right? If they want it, if they're willing to pay for it, all that stuff. So all the service provider would have to do is get this customer to buy their internet service, and on this PE, they would do, under the VRF for this customer, they would do a route target import for this, and they've now provided internet access to their customer. So that is a use case that was something that I thought was pretty cool when I first started learning this technology. It kind of I could relate when I learned that, because at the time I had a lot of questions in my mind how these service providers were doing this stuff, and it turns out it's so easy, right? It's nothing magic, and it's a way for them to increase their revenue and provide additional services to customers. So I wanted to just, demonstrate that, explain it, and just kind of give you another idea of why route targets are needed and why they're useful, and some use cases around them. So with that, I'll stop talking, and we'll meet on the next video. And like I said, we'll start to introduce a second customer. So take care.